Alright, you guys, this is the first section of unit number 3, linear and quadratic functions. Alright, a linear function. Most of you guys already know what a linear function is. It's basically an equation that makes a straight line when graphed. A linear function is a function of the form f of x equals mx plus b, or you guys have also heard it y equals mx plus b, where m is the slope and b is the y-intercept. Let me highlight those two things. Can't really see the yellow, can you? Alright, let me switch back to blue. Alright, example 1. Graph the linear equation f of x equals negative 3x plus 7. What are the domain and range? Alright, so f of x is pretty much the same as y. In this case, my m is negative 3, and my b is 7. So when I graph this, I'm going to start at 7. I'm going to start at my y-intercept. The negative indicates that I'm going to go down 3. And this is the same as negative 3 over 1. So I'm going to move to the right one. Oh dear. There we go. And there's my graph. Now this continues on forever in each direction. So both the domain and range are from negative infinity to positive infinity. Okay, I'll let you guys try this one. Average rate of change of a linear equation. The average rate of change is basically just the slope, just the rise or the change in y over the run, or the change in x. Alright, let's take a look at example 2. A strain of E. coli, I don't know how to say that, BU, 397 is placed into a petri dish at 30 degrees Celsius and allowed to grow. The data shown in the first table below is collected. The population is measured in grams and the time in hours. Plot the ordered pairs, y-x in the Cartesian plane, and use the average rate of change to determine whether the function is linear. Okay, so basically, we've just got to take this and graph it. Okay, so I'm going to do that down here. Alright, the graph should look something like this. There's a little bit of a curve. Hopefully you guys can see that. Because it is impossible to draw a straight line in such a way that all the points are connected, this is not a linear relation. This function is not linear. Okay? I'll write that down here. Not linear. Okay, let's graph the other one. Now this one, this is the graph of the second chart. This makes a perfect straight line. Let me see if I can draw a straight line. So it is linear. Okay, so that's all that linear means. Linear just means that it makes a straight line. Okay, I'll let you guys try this one. Okay, go ahead and graph it and decide if it's linear. Increasing, decreasing, and constant linear functions. Alright. Alright. A linear function, y equals mx plus b, is increasing over its domain if its slope m is positive. It is decreasing over its domain if the slope m is negative. I'm going to underline positive, negative. It is constant over its domain if its slope is 0. Okay, so for example, decide whether the following linear functions are increasing, decreasing, or constant. Alright, this one, positive slope. So it's increasing. This one, negative slope. So it's decreasing. This one, it's a fraction, but it's positive. So it's increasing. This one, there is no variable. This is like saying 0z plus 7, because all you have is the 7. This 0 indicates that it is constant. I'll let you guys do this one. Alright, modeling with a linear function. Okay, if the average rate of change of a function is a constant m, a linear function f can be used to model the relation between the two variables as follows. So basically, this equation can be applied to various situations. I'm going to show you a couple examples in just a sec. In this case, b is the y-intercept or the value of f at 0, or f of 0. Okay, book value is the value of an asset that a company uses to create its balance sheet. Some of the companies depreciate their assets using straight line depreciation. This straight line depreciation indicates that we can use a linear equation to represent the depreciation. Okay, so already we know we're talking about a linear equation here. So the value of the asset declines by a fixed amount. That fixed amount is the slope each year. I'll write this down. Here. Linear equation. This is our slope. Okay? Actually, I'm going to write that a little bit bigger. Okay. The amount of the decline depends on the useful life that the company places on the asset. Suppose that a company just purchased a fleet of new cars for its sales force at a cost of $28,000 per car. The company chooses to depreciate each vehicle using the straight line method over 7 years. This means that each car will depreciate by $28,000 divided by 7, or $4,000 per year. Okay, first part. Build a linear model that expresses the book value v of each car as a function of its age, x. Alright, so if you think about it, we're going to use v of x. Okay? Now, it is depreciating. That means the cost is going down, the value is going down. So we're going to have a negative slope, and it's going down $4,000 per year. Okay? So negative 4,000 is my, oh sorry, not m, x. Negative 4,000 is my m. That's my slope. Now, at the beginning, at 0 years, each car was worth $28,000. So that's going to be my y-intercept. Okay, so once again, this was the starting cost. This was where my x was 0. So that's my y-intercept. And it's going down $4,000 a year. That's why my slope is negative 4,000. Okay, so this is part A. Let's take a look at part B. What is the implied domain of the function found in part A? All right, so because x represents the age of the car, x has to be greater than or equal to 0. You can't have negative years, okay? So I'm going to write that down. X, we know, has to be greater than or equal to 0. Also, the value of the car can't be negative, okay? So if you were to plug in 7, because after 7 years it's depreciated entirely, v of 7 equals 0. So, right, there we go. So x has to be less than or equal to 7. Okay, so the implied domain is, I'm going to write this in set notation, x such that x is in between 0 and 7. Okay. All right. Let's see here. For C, we're going to graph it. Okay. If I make each thing 4,000, and each of these will be 1, 1, 2, 3, 4, 5, 6, 7. Okay. So at 0, 4,000, 8,000, 12,000, 16,000, 20,000, 24,000, 28,000. So that's the start. That's the y-intercept. It goes down 4,000 every year. That's 4,000 over 1. There we go. Okay. D, what is the book value of each car after 3 years? Okay, so 3 years, X represents the year, so I'm just going to plug in 3. So I've got negative 4,000 times 3 plus 28,000. I've got negative 12,000 plus 28,000, which gives me $16,000. Okay? Alright, interpret the slope. Since the slope of v of x is negative 4,000, as we said before, the average rate of change of the book value is negative $4,000 per year. So for each additional year that passes, the book value decreases by $4,000. So we just write that out. Book value decreases by $4,000 per year. Okay, did I give you guys more space? I did. Good. Okay. Last step. What will the book value of each car be? Or when, I should say, when will the book value? Sorry. When will the book value of each car be $8,000? Okay, so for this one, we were given the number of years and we were asked to find the price. Now we're given the price and we're asked to find the year, so we're going to work backwards. So we know that v of x is negative 4,000 x plus 28,000. And now we want to find what x is when v is, what was it again? $8,000. Okay, so I'm going to subtract 28,000 from both sides. So I've got negative 20,000 equals negative 4,000x. I'm going to divide both sides by negative 4,000. X equals 5. So this is what it will equal after 5 years. Alright, I'm going to let you guys try this one, and let's see here. One more example. Okay. The quantity supplied of a good is the amount of a product that a company is willing to make available for sale at a given price. The quantity demanded of a good is the amount of product that the consumers are willing to purchase at a given price. So, suppose that the quantity supplied, S, and the quantity demanded, D, of cell phones each month are given by these equations. So, this is supply, this is demand. This is a business problem. The equilibrium price of a product is defined as the price, basically the equilibrium price is when the supply equals the demand, okay? And the amount is the equilibrium quantity. They want to find out what the equilibrium price and the equilibrium quantity are, okay? So, what we need to do here is set these two equations equal to each other. So I've got 60p minus 90, or 900, sorry, equals negative 15p plus this. And then we just solve. So if I add 900 to both sides, I'm going to get 60p equals negative 15p equals 3750. I'm sorry, that should be a plus. I'm going to add 15p to both sides, so I've got 75p equals 3750. And if I divide by 75, I'm going to get p equals 50. Okay, so that is the equilibrium price, $50. The equilibrium quantity is what you get when you plug 50 into one of these equations. Let's plug it into the supply. S of 50. See here, S of 50, 60 times P minus 900. That's going to give me 2100. Alright, I'll put the rest of this on the next video.